So this is Screencast 7, MQ address space CPU. And we're looking still at the same customer estate. Just to recap, 4 ZOS systems. Now, 1 queue sharing group in production, and each ZOS has its own queue manager, or as I tend to refer to them, subsystem. And they share the queues, of course. Today's graph is going to just show subsystem MQA on sys. The others are very similar in their behavior, so just to declutter things, I'll only talk about one of them. Now this time, because it's MQ, both TCB time and SRB time are worth looking at, and I've combined them on the following graph. Compare and contrast that with Kix and DB2 before, where actually SRB time hasn't been worth graphing because it's been very small. And part of the point of this series is actually to show you what to expect from different kinds of middleware. Indeed, the whole Screencast series is all about what you might expect to see when you look at data. Now, in this case, because it's MQ, zip and GCB CPU is minimal. I'll say it again. Zip on GCP CPU is minimal because there isn't any zip exploitation to speak of in MQ. So this is a graph across a day of MQA queue manager, and you can see 4 pieces to each stack, and that's because we're going to look at SRB time and TCB time for each of 2 address spaces. So a queue manager has 2 address spaces. It has one called the chin, which handles remote connectors, that is stuff coming from outside this ZOS and indeed going out to places outside of this ZOS. The other address space, which even if you didn't have any remote traffic you'd still find active, is the master address space, which is really the central engine for MQ. Now on this graph, the master I've depicted in various shades of orangey yellow, and the blue is the chin address space. So let's start with the master. So the master at the top, basically you see there is a fair amount of TCB time, yes, but also this time you see a fair amount of SRB time. And if you look at the chin address space, you see very little SRB time and quite a lot of TCB time. And I think one of the concerns with MQ, kind of analogous to DDF but different, is what do you do if you get a sudden unrush of MQ work coming from outside? Well, I think if you're tracking the MQ CPU for the chin address space in particular, whether TCB time or SRB time, mostly TCB time in fact, you want to notice if that spikes, and you want to notice if that's a regular pattern or whether it happens at odd times of the day. So I think this sort of analysis is actually quite useful for trying to manage the traffic into and through MQ. So this is another set of address spaces, different from the DB2 and Kix I've talked about before, that you'll often see in data if you're doing analysis.